Alright, welcome to Mtare TV, and today's video we're going to look at question 4, Pure Chemistry 2017. I'm a tutor for Pure Chemistry and Pure Physics as well. So without any further ado, let's look at the question. So the question reads, using dot and cross diagrams, show the structures of the following compounds. Alright, so the first structure we need to show is what? For magnesium oxide. Magnesium oxide. We need to do what? Show the outer shells only. No need to show the first shell, the second shell, the third shell, or the fourth shell, if that element reaches that number of shells. That means if the number of shells that an element has, for example, for it to attain stability is 3, which means you don't need to show the first shell and the second shell. You need only to show the third shell only. But if an element has how many shells? Let's say 2 shells. What you need to do is show the second shell only, not the first shell. Alright, so let's look at on how we can draw that. So here you will notice that this is our ionic compound. This is an ionic compound. How did I notice that this is an ionic compound? By identifying a metal and a non-metal element. When you combine a non-metal and a non-metal element, you form ionic compound. Once you have formed an ionic compound, what happens? What happens is that this element, the metal, will donate electrons to the non-metal. So for example, here, if you look at the diagrams here, you're supposed to put them in brackets. Here, I've only showed the outer shells only, and also here I've only showed the outer shells only. Following this instruction. So here you also notice that I've put a 2 plus and a 2 minus here. These are very important when you're drawing ionic diagrams for dot and cross diagrams for ionic compound. So this 2 plus simply means that magnesium has donated how many electrons to oxygen? 2. Meaning that it has lost how many electrons? 2 electrons for it to attain stability. Same applies to oxygen. Oxygen has received 2 electrons for it to gain stability. So this is how you draw the dot and cross diagrams for magnesium oxide. Alright, we'll move on to the next question, the next part of the question. Alright, so the next question reads, carbon dioxide, show all the shells. So now here, if you pay particular attention, you notice that carbon and dioxide are non-metals, right? And they form a compound. If they form a compound, we call that compound a converted compound. So for you to draw a dot and cross diagrams for a converted compound, you need to know that electrons are shared, not lost or gained, like in the ionic compound. So here, the diagrams will be like this. There will be no brackets outside or anything like that. Rather, the atoms will be joined together. Why? Because electrons are being shared. So in this case, carbon donated how many electrons? 1 and 2. And also this side 1 and 2. This atom of oxygen donated how many electrons? 1 and 2 as well. Making a total of 4 here. And also here 4. But we know that for an atom to gain stability, in the second shell, you need to have how many electrons? You need to have 8 electrons. So let's count to see if there are 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. This simply means that this atom is balanced. If you do the same, you should count also for carbon and oxygen to also be balanced. So that's how you draw a dot and cross diagram for carbon dioxide. Alright, so we move on to the next question, to the next part of the question. The next part of the question reads, state any 2 differences in physical properties between ionic and converted compounds. Alright, any 2 differences in physical properties. Alright, the physical difference between ionic compound and converted compound is number 1. There are ionic compounds have higher melting point and boiling points. Then While for the covalent compounds, they have what? Low melting point and what? Boiling points. Then number 2, ionic compounds. The other name for ionic compound is what? Electrovalent what? Compounds. So ionic compounds, they conduct electricity in molten or aqueous state, while covalent compounds do not conduct electricity in molten or aqueous state. That marks the end of the question. So in the next video, we're going to look at question number 5. Alright, don't forget to subscribe and leave a comment.
Are you a parent or student looking for a school that delivers real results? Atlantic Study Centre, Cambridge School is the right choice for your child. Located at House 04, Chainama Road, we offer Cambridge secondary education designed to build strong academic foundations and confidence in learners. At Atlantic Study Centre, we focus on good results taught by qualified and experienced teachers in a disciplined learning environment with small class sizes to give every learner personal attention. This ensures better understanding, close teacher-student interaction, and improved performance. We enroll learners aged 8 to 13 years with affordable fees to make quality education accessible to more families.
Enrollment details and periods are available from Ms. Michelle, who will guide parents through the full enrollment process.
Although we are still developing facilities, our strength lies in academic excellence, discipline, and committed teaching staff, because strong teaching matters most. School: Atlantic Study Centre, Cambridge School. Location: House 04, Chainama Road. Level: Secondary, Cambridge. Contact 2660-772-999-997. Email atlanticstudy11@gmail.com. Enroll now and secure your space today to receive quality education that shapes a better future.